All right, timer is going. Okay, so we're starting section 1.1 today. This is functions. So if y'all remember functions from Algebra 1, it's like the little data thing where you put something into the machine and it spits something out. So you have your input and your output. And remember, a function is when you have an x value that corresponds to y value, but x cannot repeat. So do y'all remember that from your STAR test? When it said identify the function, it gave you all these points. Y could repeat, but x could not. Okay? So definitions starting here. A relation is a correspondence between two sets. If x and y are two elements in these sets, and if a relation exists between x and y, then we say x corresponds to y, or that y depends on x. And we write it as x depends on, or x is the input and you get the output y, or you write it as a point x, y. Okay? So x is your input. So your input is x and your output is your y. So it's just the same as before. Now, definition of a function. Let x and y be two non-empty sets. A function from x into y is a relation that associates with each element of x exactly one element of y. So that's where x cannot repeat. That's what that means. They use a lot of jumble to just say something really simple. X can't repeat. Okay? In other words, for a function, no input has more than one output. Again, x cannot repeat. So make yourself a note. X cannot repeat. So for every domain or input, so this is the input, there is exactly one x, one input, and then it can output to all the y's. And yes, the y's can repeat. I guess one example, let me see if I can fit this on here. If I did these two little sets here, so if I had an x value and then I had some y values over here, if it was like this, where the x repeats, this is not a function. So x cannot repeat. Over here, this x can go to y and this x can go to y, but this x can't go to this x. This x can't go to this y and this y. Okay, it can only go to one. Now, domain is your set of inputs for the function. So your domain is your x values, and your range is your y values. So we say that the set x is called the domain, or your set of inputs of the function. For each element of x in x, the corresponding element y in y is called the value of the function at x, or the image of x. The set of all y values in y that depend on x values is called the range, your set of outputs of the function. Now, determine. So this is going to look like some of the questions from your STAR test, because it's asking you to determine whether a relation represents a function. Determine which of the following relations represents a function. If the relation is a function, then state it as a domain range. So look at your x values. You have -3, -2, 0, and 1. X does not repeat, so this is a function. So function, check. Now list it. Your domain, so your domain is -3, -2, 0, and 1. And it's the squiggly brackets. I don't know what those things are really called. I feel like they have a name. We just call them squigglies. And your range is all your y values. So that's 9, 4, 0, 1. And that is how you list your domain. You're stating the domain and the range of the function. All right, B. So I've got 2, 4, 3, and 2 again. So this is not a function. It is not a function because the 2 repeats. Okay, the next one. I've got -2, 4, 3, and +2. So this is a function. And my domain is -2, 4, 3, 2. And my range is 3, 1, -2, -1. All right, in D, I've got 1, 4, 1, 4. So the 1s repeat and the 4s repeat. So this is not a function. X equals 1 and x equals 4 repeats. All right, do you have any questions? All right, sometimes it's helpful to think of a function f as a machine that receives input, a number from the domain, manipulates it, or does the math, because there's always like 2x plus 5, that's a function. So it does something, the machine does some kind of operation, and then it spits out a output or your range. So it only accepts numbers from the domain of the function. For each input, there's exactly one output, which may repeat for different inputs. So remember, y equals f of x. Y equals f of x. So those are the same things, all right? So f of x is your output. X is your input. F of x is your output. The variable x is called the independent variable because it can be assigned any value in the domain. Y is the dependent value or variable because the value depends on x. Your answer depends on the question. Okay, if your question is x equals 5, then depending on the function, the output will depend on if x is 5 or if x is 7. Okay, so y depends on x. So y, f of x, or y depends on x. Output depends on the input. All right, so let's do some practice. So for the function f defined by f of x equals -3x squared plus 2x. So we go to lunch in 2 minutes, okay? So they're saying that this is the function we have to use for all of this, okay? They're telling me that x is 3. So everywhere you see an x value, put a 3. So f of 3 equals -3 times 3 squared plus 2 times 3. So -3 times 9 plus 6. -27 plus 6. So -21. So when x is 3, y is -21. All right, we have time for one more. So this is telling us to add the functions. So they're saying f of x plus f of 4. So f of x part is going to be this right here. So -3x squared plus 2x plus, now rewrite it, but this time replace the x's with 4's. So we got negative 3x squared plus 2x plus negative 3 times 16 plus 8 so minus 48 plus 8. Negative 3x squared plus 2x minus 40 is the final output. Y'all can read that okay? Okay. So this piece right here, this piece right there was the f of x part. And this piece right here is the f of 4 part. Okay. All right, so here we go. So now, this time the number is in front of the function instead of as an input. So you're just going to multiply that function by 5. So we're going to go, let me change colors where it doesn't blend. So we're going to go 5 times, and the function is negative 3x squared plus 2x. So that gives me negative 15x squared plus 10x. Okay, because it says to multiply 5 by the function. So we're multiplying 5 by the function. All right, now moving on. Now we have a negative sign, so D has a negative sign in front of the function. So this one is going to be negative times, the function is negative 3x squared plus 2x. So we're going to distribute that negative sign to all the pieces. So this is 3x squared minus 2x. All right, this time you're going to replace all the x's with negative x's. So we've got negative 3, negative x squared plus 2 times negative x. So all I did is replace those x's up there with a negative x. So we've got negative 3 times, well, what is negative x squared? Well, that's going to be positive x squared minus 2x, because 2 times negative x is negative 2x. So we wind up with negative 3x squared minus 2x. So make sure that you're using those parentheses where they're needed. And then last, we're going to replace all the x's with x plus 1. So this one's going to take a little bit of space, because notice when we replace that x with x plus 1 and it's squared, that's going to give you a trinomial when you multiply it through, okay? So we're going to go negative 3 times x plus 1 squared plus 2 times x plus 1. So I'm replacing all the x's with x plus 1. So we've got negative 3 x plus 1 times x plus 1. And this is 2x plus 2. Do y'all remember this from your algebra class? Well, if you don't, then it's a good review. So now I've got negative 3. So x times x is x squared. X times 1 is 1x. 1 times x is 1x. 1 times 1 is 1. X squared plus 2x plus 1. Slide this up. I'm going to have to use their space over here. Negative 3x squared minus 6x minus 3 plus 2x plus 2. Now I can combine these like terms. So negative 3x squared, negative 6x and 2x is going to be negative 4x. Negative 3 plus 2 is going to be negative 1. So this one becomes negative 3x squared minus 4x minus 1. All right. I'm going to scroll this up. I'll leave it so you can still see it. All right. Next, the definition for the difference quotient of a function f at x is given by f of x plus h minus f of x over h, where h cannot be 0 because you cannot divide by 0. All right. So now it says find the difference quotient of a function by plugging in what they're giving you. So we're going to take this function f of x equals 3x minus 5, and we're going to plug it into. So can I scroll this up? Does everybody have everything written down? Okay, so I'm going to scroll it up because I need the space. So you're going to take f of x plus h minus f of x over h. And you're going to replace all of your x's with x plus h. So you're going to have 3 times, so replace this x with x plus h minus 5. And then we're going to subtract 3x minus 5. Because it says f of x, well, f of x is 3x minus 5, so we're replacing that. And then this one is f of x plus h, so I had to replace the f of x, or the x, with x plus h. And it's still over h. That didn't change. So this one came there. So now you're going to multiply through and then do your cancellations and see what you wind up with. All right. So 3 times x is 3x. 3 times h is 3h minus 5. Distribute this negative. Looks a little bit better when you can get rid of all those parentheses for sure. So now, if you start combining your like terms, you should notice 3x minus 3x, those cancel. Got 3h. Got negative 5 plus 5, so those cancel. So I'm left with 3h over h. The h's are going to cancel. So I'm left with 3. So 3 would be your final answer there. So this is about substitution, and it is a little confusing at first, but just pay attention to what you're plugging in, and then do your examples, or do your problems the way the examples are, and you'll kind of start to see it. All right, part B. So again, I'm going to take the f of x plus h minus f of x over h. So I'm going to take this equation, and I'm going to replace the x with x plus h. So I'm going to have negative 2 times x plus h plus 1. So this is the first part, minus negative 2x plus 1, because that is the actual function. And it's over h. So I'm going to distribute the negative 2. Then I'm going to distribute the negative. And then you can go through and see what cancels. Negative 2x plus 2x cancels. 1 minus 1 cancels. And this h cancels with this h because that's all that's left, because you have negative 2h over h. h's cancel. You're left with negative 2. Are we good? All right. All right, page 3. The domain is the largest set of real numbers for which f of x is a real number. In other words, The domain of a function is the largest set of real numbers that produce real outputs. So, tips for finding the domain of a function defined by an equation. Start with the domain as the set of all real numbers denoted, that capital R. We did that the very first day. If the equation has a denominator, so if it's a fraction, exclude any numbers that give a 0 in the denominator. So remember, you cannot divide by 0. So denominator cannot be 0. All right. If the equation has a radical or even index, so square root, so you can't have a square root, a fourth root, a sixth root, okay? So if it has a radical and the index is even, exclude any numbers that cause the expression inside the radical to be negative. So remember, you cannot have square roots that are negative. So we cannot square root a negative. I can square a negative, but I can't square root. You cannot take the square root of a negative. So it has to be greater than 0. So now, let's look at these examples. So it says to find the domain of a function defined by the equation. So find the domain of each of the following functions using the interval or set builder notation. So notice that we have x minus 5. I'm going to enlarge this piece and then I'll slide over. So that means that cannot be equal to 0. So that means x minus 5 equals 0. So x is 5. So that means since this cannot equal 0, x cannot be 5. So when you're looking at this on a number line, if this is where 5 is at, you can have everything to the right of 5 and everything to the left of 5, but not 5. X cannot be 5. It can be all the numbers except 5. Because 5 will give you a 0 in the denominator, cannot divide by 0. Okay? So now you're going to look at negative infinity to 5 as an interval, and 5 to infinity as the rest of the interval. Or, squiggly, so depending on how you notate it. So using interval or set builder notation. So interval or set builder. So either one of these is correct. So your choice. All right, let's look over here at B. It says f of x equals x squared minus 9. So that just means that I can plug anything in for x, anything that's real. So all real numbers. So if it's asking me for the domain, I can list all real numbers because I can plug anything in for x. There's no denominator to worry about being 0. So now I want to put in here some interval notation marks. So these are things you need to know when you're writing interval notation. So you have less than, greater than, cannot be, not equal, and open parentheses. All of these things right here mean that it cannot be equal to that number it's touching. So like over here, we had this parenthesis, which meant it cannot be 5, okay? But if you have less than or equal, greater than or equal, a solid circle, equal signs, and then brackets, these are things that say it can be equal. So like if you've got so you're starting here and you're ending here. So a parenthesis means it cannot be equal to that number. Brackets mean it can be equal to that number. All right, you could even have this, which means it can be equal to the start and the finish. So just keep in mind, starting, ending, brackets, parentheses, they have meanings, okay? So this one is cannot be equal, and this is can equal. And that's whatever number you're dealing with. All right, so let's look at C. So f of x, so this is the one where we have the square root of 3 minus 2x. So that means that this piece inside has to be greater or equal to 0. Because it can't be negative because you can't take the square root of a negative. So we need to find out what number it cannot be. Does that make sense? So take your 3 minus 2x has to be greater or equal to 0. So I'm going to subtract 3. And I'm going to divide by negative 2. Remember, when you divide by a negative, the symbol flips. So x has to be less than or equal to 3 over 2. So make yourself a note if you forgot. Flip the inequality. When you multiply or divide by, well, not just negative 2, but any negative. So on a number line, we're going to have a closed circle for 3 over 2. And since the arrow is pointing to the left, then it's going to be from that number, anything to the left. It can be equal to 3 over 2 and everything beyond that. So beyond to negative infinity, and this goes to positive. So what does that look like? Well, you're going to have parentheses, because anytime you're dealing with infinities, it's always going to be parentheses, never brackets. To 3 over 2. Or your set builder. So that is what your graph would be notated as, set builder or your interval notation. All right, last example on this one. So now we have a fraction and a radical. Okay, so not only can your 4x plus 2 not be a negative number, but when I take the square root of it, it cannot be 0. All right, so it cannot be equal to 0, and it has to be greater or equal to 0. So combine those. It has to be greater than 0. Oops, sorry, I didn't know it went that far up. Because here we know that it can't be 0, so that takes away this line right here to where it just has to be greater than 0. Okay, so let's find out what that number is going to be. So take your 4x plus 12. It has to be greater than 0. So x has to be greater than -3. So think about your graph. So it's going to be open circle. And since your arrow is pointing to the right, then it's going to be all the things to the right. So -3 and beyond, but not -3. It can be -2.99, but not 3. So what does that look like as interval notation? So we go -3 to infinity. Oops, not brackets. Not ever brackets. Or your set builder, x such that x is greater than -3. All right, last part. I know there's a lot to these notes. So you have function operations. So the sum is f plus g. So it's defined by f plus g of x. So you just pull them apart, f of x plus g of x. The difference, f minus g, is notated as f minus g of x. So again, f of x minus g of x. Product means you're multiplying, so f times g of x is f of x times g of x. And the quotient, f divided by g, is the function defined as f divided by g of x is f of x divided by g of x, but g of x cannot be 0. Lots of rules. So what happens when you form the sum, difference, product, and quotient of two functions? So they're going to give us two functions up here. They're already given to us. F of x is 2x minus 4, and g of x is -3 plus 6. So we're going to add them together. So it says f plus g of x. So remember, that just means f of x plus g of x. Well, they gave me f of x as 2x minus 4. G of x is -3x plus 6. 2x minus 4 minus 3x plus 6, -x plus 2. So you're just combining like terms, just adding two binomials. All right. In part B, they want me to subtract them, so that just means f of x minus g of x. Be careful of the negative sign. That means you're going to have some parentheses involved. So f of x is 2x minus 4 minus g of x, which is -3x plus 6. 2x minus 4 plus 3x minus 6. 5x minus 10. Am I on the wrong one? All right. C. All right, I want to show y'all something. I want to do this f plus g of 1. Okay, what happens when it's an actual number? Does that make sense? It's in my set of notes that I have the key for, but when we remade the notes, we left that one off, and I think it's important because you're probably going to have one in your notes or in your assignment. What if we did, just over here to the side, do f plus g of 1. So remember, that's going to be f of 1 plus g of 1. So I'm going to plug in 1s everywhere I see an x in both of my functions. So it's going to be 2 times 1 minus 4 plus -3 times 1 plus 6. 2 minus 4 minus 3 plus 6. So 2 minus 4 is negative 2. Negative 2 minus 3 is negative 5. And negative 5 plus 6 is 1. So just an extra bonus example here. So when they give you a number, just plug the number in. Follow the same rule, though. Questions? All right, let's look at C now. So here we're multiplying them. So it's going to be f of x times g of x. So 2x minus 4 times negative 3x plus 6. This is just using your FOIL method or your double distribution to do this. 2x times negative 3x, negative 6x squared. 2x times 6 is 12x. Negative 4 times negative 3 is positive 12x. Negative 4 times 6 is negative 24. So you get negative 6x squared plus 24x minus 24. All right, and then we have f divided by g of x. So this is going to be f of x divided by g of x, where g of x cannot be 0. So 2x minus 4 divided by negative 3x plus 6. But since the denominator cannot be 0, then I need to figure out what x cannot be. If the denominator cannot be 0, so negative 3x cannot be so x cannot be 2. So I'm going to factor out a 2. I'm going to factor out that negative 3, because what happens is that allows me to cancel this out right here. So I'm left with negative 2 over 3, where x cannot be negative, where x cannot be 2. Sorry, that's messy. So x, I keep writing negative. I don't know why I want to write a negative so bad. Normally, I don't want to write negatives. So just so you can see the picture of the graph. So if this is your 2 right here, and where you have your negative 2/3 over here. So that's what it would look like on a graph. So it cannot be 2. So 2/3 is your answer, which negative 2/3 is your answer, and it falls within the range. Okay?